Good morning, students, or possibly I should say good evening, or depending on the time when you're picking up this video, who knows. It's actually 8 o'clock in the evening here in Smithville, and I just wanted to take some time to give you a little bit of additional information about the assignments that we would have talked about had we met on the snow day a week ago Saturday. The material to be covered on that particular lecture was sections 6.3 through 6.7 and 7.1 and 7.2. These are the numbers that will correspond to the numbers in your practice exercises. 6.3 is on simple interest, 6.4 is on house expenses of various kinds, 6.5 car expenses, 6.6 commissions, salaries, hourly, payroll, that sort of thing, and 6.7 on checkbook balance. And then we get into chapter 7. We're only going to would have covered two sections, 7.1 and 7.2 in chapter 7, which deals with statistics and probability. Now hold on, don't get nervous about that thought of statistics and probability, because a lot of it's graphical, and I think there'll be some interesting material for you. The material that we're covering right now really is all involved in just applying equations of various sorts. We have finished all of the work on basic math computational methods. You've learned all you need to know, basically, to do most of the math that will be involved in your life. So from here on out, we're applying various equations. And then finally, in the next to the last week, we're going to talk about algebra in general. 6.3 starts out with a talk of basic simple interest. The equation that is involved with simple interest is that the principal times the annual interest rate times the time in years is equal to the interest. Now write that down. Principal times annual interest rate times time in years equals interest. You apply whatever variables you'd like in that equation. I have a tendency to call principal P annual interest rate small I, time in years usually small t, and interest capital I. But you know, those are my letters. You pick whatever ones that you want. So the maturity value formula for any simple interest loan is that the principal plus the interest equals the maturity value. The monthly payment for a simple interest loan is the maturity value divided by the length of the loan in months. Write that down. You'll be applying it with a few problems this time. The chapter goes on to talk about compound interest. Compound interest in general, if you think about it, is earning interest on interest. If you had a loan or a bank account that was calculating and giving you interest every month, and then adding that interest to your balance, so the following month you're actually earning interest not only on your original deposit but the interest you've already earned. That's called compounding. There's a fairly complicated equation that calculates compound interest. Many of your calculators have compound interest formulas on them, but not all. So I've included in the email that I sent out a few days ago some compound interest tables, and those are the tables that you'll use for the various questions that come out in 6.3, which is compound interest. The instructions for how to use those tables are actually right on the page with the tables. So take a look at those. You'll be using those. Don't see these problems as difficult. This would be my request of you. Just relax and try to enjoy yourself with these. We're really involved in life processes now. Real estate expenses. The equation is the purchase price minus the down payment equals the amount of mortgage. Sometimes points are applied to a mortgage loan. The equation is the number of points times the mortgage is called typically a loan origination fee. Sometimes you have to pay a certain percentage down payment. Your down payment would be that percentage times the purchase price. The percentage times the purchase price. So those kinds of terms are involved for those of you who have or will in the future be buying a home. For a fixed rate mortgage, the monthly payment remains the same throughout the life of the loan. For a variable rate mortgage, it changes periodically. We're going to talk basically about fixed rate mortgages. Mortgage interest is compounded. It's not simple interest typically. The monthly mortgage payment minus the principal in any given month is the amount of interest that you paid in that month. You can determine these numbers from your tables, or for some of you from your calculators. There's also a section 6.5 on car expenses. Talks about things like insurance costs and fuel costs and sales tax. Sales tax is the percent sales tax times the purchase price of the car. A lot of you have already done this many times. Continuing expenses for a car are things like insurance, gas and oil, maintenance, and of course your monthly car payment, which, by the way, you can compute yourself given the kinds of tables that I've given you. That kind of information will typically give you the advantage when you're dealing with a car salesman too, by the way. Don't forget that. Commission rate times total sales is the amount of commission that you would earn if you are involved in commission sales. Hourly wage times number of hours worked is your total wage. On the other hand, salary per pay period, keep track of your interest in these equations. I'm sorry, your units in these equations. Salary is salary per pay period. So you multiply the salary times the number of pay periods, and you wind up with a total salary. The total salary, the units, would therefore be dollars. Bank statements, you can actually look on the back of your bank statements to get the equations that are used in balancing your bank statements. But basically what it amounts to is you take your balance, what you think the balance is, add to your current balance all the checks that you've written but wasn't shown on the bank statement that you got, and add any interest paid on the account. And from that, subtract any service charges that you know about that didn't show up on your bank statement, and any deposits that did not show on your bank statement that you know that you've made. You subtract that off. The difference is the balance that you compare to the balance on your bank statement. If they're the same, it's said that your bank account is in balance. If they're different, there's an error someplace, and it's not always yours. So keeping track of your bank account balance is a very, very good thing to do. Chapter 7, I'm just going to hurry through. It gets us into statistics and probability. And basically what we're going to cover, would have covered during the snow day, what you will cover in the exercises for 7.1 and 7.2 are looking at what are called pictographs. There are examples in your exercises. You can see what a pictograph looks like, and also circle graphs. Circle graphs are used to compare parts of a whole. Just keep that in the back of your mind, to compare parts of a whole. For instance, if you had New York City population data for 1850, 1900, 1950, 2000, you could plot a line graph of that. But there's really nothing in that information that will allow you to use a circle graph. So each kind of graph is used for specific situations. Bar graphs, examples again in your programs, in your problems. Typically bar graphs are used when 3 or more variables are to be compared. What the book calls broken line graphs, I just typically call it a line graph, is the kind of graphical procedure you use to plot trends. This will involve you doing programs up through drill sheet section 7.2c. Study those things, do your test, take-home test, which, by the way, take a look at that very closely, especially the last few pages. I would really expect all of you to get 100% on this particular take-home test. Sorry I missed you on the snow day. Actually had a little video to show you where we could celebrate Christmas together, but have a Merry Christmas.